So for your math OGT, some of the types of questions will involve areas or volumes. And there are a lot of different shapes on this formula sheet. This is the actual math OGT reference sheet, at least the top part of it. If you want to see the whole reference sheet, you can just Google OGT reference sheet. OGT math reference sheet. You should include the word math. So these are formulas you don't need to have memorized. You can look them up as you take the exam. So when you're trying to decide, well, which of these formulas do I use? The first thing you have to figure out is, well, am I looking for area or for volume? There'll be questions with shapes, and there'll be some keywords that indicate whether it's area or volume. One of the keywords is actually the word area. They may just include the word area. That happens a lot of the time, is just including the word area. They could say maybe you need to paint something or cover something. Or you'll see in the units, area is over a space, the inside of a space. So in the units, like let's say each side was measured in inches, the units for area would be inches squared, or they can actually use the words. Instead of writing inches squared, they would write square inches or square centimeters. For volume, again, they may use the keyword of volume. That's one of the normal ways they will ask it, or they'll say things like you're filling something. Maybe you're drinking from a soda can or a juice can. Anything that fills up a space is a volume. So once you've identified that, then you need to ask a second question. Once you've identified, okay, I'm doing area or I'm doing volume, then you need to say, well, what shape am I finding the area or volume for? Usually there will be a picture, or we'll use the words. So when we tried last time, I went through and showed each shape. I'm going to go ahead and just go to the problems, and we'll see the shapes as we go through. If we miss any of the shapes, then I'll come back at the end and talk about those shapes. So for this problem, this was taken from one of the old math OGTs. It says, Mitchell is planting tulip bulbs in a rectangular planter with the dimensions shown. So as you're going through the problem, it can also help to underline keywords. Rectangular planter, that's a keyword. And they give you a picture, so it's easy to understand exactly what the shape is. Then it continues, Mitchell plans to fill 3/4 of the planter with soil. This is another key part. Knowing that it's only 3/4 of the way full is good information. So then the final question, what you actually need to answer, is how much soil will Mitchell need? If he fills up this planter, not all the way to the top, but close to the top, how much soil is that going to take? So it did not say the word area or volume. That didn't give us that basic keyword, but it did say he plans to fill the planter. We're putting stuff inside the shape. Area is either flat or it's the outside of the shape. Volume is inside of the shape. So if we're going to fill it, we want to go to our volume formulas and decide, well, which one applies here? We have this box shape that they've called a rectangular planter. So we have cone, cylinder, pyramid, rectangular prism, right prism, or sphere to choose from. So when we look at that list, there's one that matches up pretty well with the words we have here. It says rectangular planter, and it says down here the words rectangular prism. Those are the same things. A rectangular prism, that's what we use for boxes. Sometimes maybe they'd have a problem about like an old flat eraser, not like the eraser on the end of your pencil, but a flat separate eraser or anything that has this kind of cube shape. So on a rectangular prism, the important parts are these letters, L, W, H. Each stands for something. The L, I know it looks like a 1. Notice that they have a fancy one with the curl at the top. So even though it looks like a 1, it is not the number 1. L is the length of the prism. W is the width of the prism. And H is the height of the prism. So these stand for length, width, and height. And as we go through, if you do have any questions, please just let me know. Either unmute yourself or send a chat message. I'll keep an eyeball on the chats. If not, I'll just keep going. So length, width, and height on the rectangular prism, they've basically just written it out for you. We have our length, we have our width, we have our height, and the formula has the letters touching each other. When they're directly next to each other, that doesn't mean, so our length is 22, our width is the middle one, that's 9, and our height is 8. It doesn't mean we just have the number 2298. Those actually being next to each other means to multiply. When you have two letters touching, even though they don't write the multiply into the formula, it does mean multiply. This means length times width times height. So our numbers, 22 times 9 times 8. You are allowed to use a calculator on the OGT, and they usually provide it. So when you get to a problem like this, just plug it into a calculator. I have a separate one that I'm typing it into right now, and that gives us 1,584. Now, just like area, we knew something was area because it was square units. For volume, they would use the word cubic. Since it's a volume, we use cubic inches, or they could have written inches cubed. And we're also tempted to say, hey, I see this number is on my list. Answer choice B matches the number I just got. I think I'm done. Always double check that you've answered the whole question. They love to give you answers that are just partway through the process, but you still have to do more. So it looks like you've finished, but you've got to keep going. So the reason we have to keep going on this one is we found the amount that would fill the entire box. This is the volume of the entire planter. The question asked us to fill it 3/4 of the way full. So we need to figure out the amount of soil if it's not all the way to the top. When you're filling something, you can actually just multiply by that fraction. 1584 times 3/4. That will give us how much soil is going to fill it up 3/4 of the way. I'm going to actually pull up my computer calculator this time so that I can show it on screen. When you multiply something like this out, it's a little more complicated. So your calculator will look a little bit different than this, but you still can type it in the same way. We type in 1584 multiplied by a fraction 3/4. This calculator, though, doesn't have a fraction button. So when we want to write it into the calculator, we say times 3 divided by 4. A fraction bar is a form of division. This is really 3 divided by 4. So when you type it into the calculator, 1584 times 3 divided by 4, and then you hit equals, gives you 1188 cubic inches. You can also use some logic here. If we know the entire box is 1584, but it's 3/4 of the way full, we know it's not all the way full. There's literally only one number that's less than the entire box. So it had to be A, even if we didn't calculate the exact amount. So watch for that. Sometimes the logic part of it can't be applied. If they had 2 numbers that were smaller, you might not be able to figure out which one, and you have to calculate it. But since there were only 1, that's our answer. So again, I'm taking all these problems from old OGTs. This is another one. I don't remember which year each one is from, but there's a couple released online. You can actually search for them again using Google and look them up if you want to look at a whole bunch of problems. So this problem says, the city flag for Salina, Ohio is shown below. The flag has a total area of 5,472 square centimeters. So total area, that's the entire shape. If we filled the entire inside, we had to paint it or something, it'd fill the entire shape. In the center of the flag is a circular design. The diameter of this design is 48 centimeters. Some more key information. What is the approximate area of the flag that is not covered by the circular design? So more key words here. We want approximate area not covered by the circular design. We don't want the circle. So this time we don't have to look for any kind of secret keywords. They just told us straight out we have area. It says the total area. It says to find the approximate area. We know we can ignore the volume formulas for this problem and just look at area formulas. So they outright told us the total area. We don't have to do any calculation there, but we do need to find the area of the circle. To find the area not covered by the circle, let me kind of highlight it. It's everything outside of the circle. So we want the circle to go away. We want to take it out of the total area. So we're going to do the total area minus the area of the circle. In order to do that, we first have to find the area of the circle. So we look at our shapes. We have parallelogram, rectangle, trapezoid, triangle. None of those are circles, but then they have separate specific circle formulas. And specifically, we want area. C stands for circumference. That's kind of like perimeter on a shape that's made of straight lines. Circumference is if you measured the outside edge of a circle, that's that distance. A stands for area. Pi is the symbol for a specific number, 3.14, which they show you to the side. And they give you the fraction, but we really just need the decimal most of the time. I don't think you ever really need to use the fraction. And then R stands for the radius of the circle. And then squared is just a math operation. It's like adding or subtracting. It's math you actually have to do to the numbers. So we need a radius. The number we need to plug in is radius, but the number they gave us is diameter. They said the diameter is 48 centimeters. So when you look at a circle, the diameter goes all the way across and it goes through the center. It can't just go to the side of it. It's got to go exactly through the center. And it's all the way across the circle. In this case, this is 48 centimeters. And the radius only goes halfway across the circle. It could be either side. This is a radius, or from the center to the left, that's a radius. It's just only halfway across. So if they give you diameter, that is not the number we plug in. And I guarantee that one of the answers is what you would get if you plugged in 48. Like I said, they kind of try and almost trick you. They're like, we know a lot of students will plug in 48. We're going to put that on the answer choice list. Instead of using 48, we want to find the radius by taking the diameter and dividing it by 2. If radius is only halfway across, we do diameter divided by 2. So that gives you 24. Still centimeters. And now we can plug it into the area formula. We want to do 3.14 multiplied by again, when you have anything just touching each other, but they don't put an actual math symbol. It's not pi plus r or minus r. This is pi multiplied by r. They assume you know that there's really multiplication here, even if it's not written. So 3.14 times 24 squared. Now, order of operations is important here. We can't just do 3.14 times 24, get an answer, and then square that. Order of operations, you may have seen this. Please excuse my dear Aunt Sally. Oh, don't forget the D-A-S. Or PEMDAS. This tells you the order to do math in. When we read, we always go left to right. When we do math, we always follow this order of operations. So first thing to look for is parentheses, which we don't have any, so we skip that one. Next, we look for exponents. That's what the E stands for, and we do have one, 24 squared. So we're going to actually do that piece first before doing any multiplication. Again, we need a calculator. I don't know what 24 squared is. Most people do not, just off the top of their heads. So 24 squared, some calculators have a squared button and you just hit it. Or 24 squared means to multiply 24 times 24. Squared means use the same number 2 times and multiply it together. That gave 576. And then we just finish 3.14 times 576 is 1,808.64. So none of the answers say that exactly, but it did say to approximate. When it uses the word approximate, it's going to round. It didn't state where to round to, but we can look at the answers. We want to round to the nearest whole number. There's only one close, so we know for sure which one it is. But just to talk about rounding, if we want to round to the nearest whole number, we look at the 8 and decide, is that 8 going to stay an 8, or does it round up to a 9? Is it closer to an 8 or closer to a 9? And we look at the next number to determine that. If this number is 5, 6, 7, 8, or 9, 8 will round up. If this number had been 1, 2, 3, 4, 1, 2, 3, 4, or 0, then this would have stayed an 8. So this rounds up to the 1,809. Okay, and I fell into the trap myself right there. I didn't check before saying, oh, that's my answer, it's on the list. It's really easy to do, easy to forget about. Always double check, make this second nature. Did I answer the question? We just found the area of the circle. 1809 is the area of the circle. That is not what they asked for. They asked for the area of the flag not covered by the circle. I almost forgot to go back and do the total area minus the area of the circle. So we take the total area, 5472, minus the area of the circle, and we plug that into a calculator. Again, working with some big numbers. You can solve it by hand, but that's really time consuming. It's just quicker, type it in. 3,663. So again, watch for that trap. Always, always make sure you've answered the question, because it's really easy to feel proud and say, I did this, I'm done, I have that answer, it's on the list, we're good. But you might have to go further. So the next one, Madison is filling balloons with helium. So again, keyword, filling. We should know from the word filling exactly whether we're working with area or volume. In this case, volume. Filling means volume. So we don't need any of these area formulas. When full, the balloons are nearly spherical in shape. There's another key word, with a diameter of 12 inches. What is the approximate volume of each balloon when it's full? So we've identified from the filling that it's volume. Then it says it's nearly spherical. So we look at our possible options: cone, cylinder, pyramid, prism, right, prism, sphere. We've already talked about how rectangular prism is basically a box. A sphere is like a basketball or baseball or a full balloon. It's a round ball, but the fancy math term for it is sphere. So now that we know which formula we need to use, we've got to use the volume formula for sphere. We've got to identify again, what does this formula actually mean? There's a lot of multiplication that they don't show you is multiply. This is not 4/3 divided by pi. This is 4/3 multiplied by pi. And same thing, pi is multiplied by r, which, just like our circle problem, stands for radius. Now you've got to be a little flexible, because sometimes they will just give you radius. This question gives you diameter again, but you've got to make sure and look and say, okay, what did I get? I got diameter. We learned from the last problem that when you have diameter, to find radius, we divide by 2. If we do 12 divided by 2, this gives us a radius of 6. So be flexible though. If it said radius of 12 inches, we'd use the 12. We had to find the radius in this case, and now we can plug it in. So our formula is the 4/3 pi r cubed So this means 4/3 times pi. Pi, they told us it's over in circle, but if you ever forget what pi is, go to the circle part of the formula sheet. It's 3.14 times radius cubed, so times 6 to the third. So to the third power, that would be 6 times 6 times 6. We'd use 3 of them. But when we plug this in, we follow order of operations again. So we don't always just go left to right. We look for parentheses, which we don't have. We move on to exponents, which we do have. So 6 to the third. On this calculator, it's an XY button. I think on the calculator you're going to use, it's a different button. So you can do 6 to the third, or if you're not sure which button to use, you can do 6 times 6 times 6. Do it 3 times to get 216. I'll try and dig out my calculator. I haven't worked with it for a little bit because we haven't been doing the OGT prep for a little bit, but I do have the specific calculator you're going to use. So for next time, I'll make sure to have that so that I can talk specifically about that calculator. So now we've done our exponents, and now we focus on multiply and divide. This is actually kind of grouped together. If there's only multiply and divide left, we go left to right. Same thing with add and subtract. If there's only add and subtract, we go left to right. So on this problem, we do have divide. Remember the fraction, even though that's a fraction bar, that's really a division bar. So we're just going to type this whole thing in from left to right. And if there is a fraction, always start with the top of the fraction, the numerator. So 4 divided by 3 times 3.14 times 216 gives us 904.32. So again, we don't see that exact answer, and we've got to double check, did we answer the question? We just found the volume of the sphere. So looking at the question said, what is the approximate volume of each balloon? Volume of the sphere. This is the correct answer. This time we don't need to keep going. It gave us just one step instead of having to do multiple steps. It did also say to approximate, so this time the approximation is a little bit different. This time it goes down even further. It rounded to the nearest hundreds instead of like the very end number. So 904.2, they said this zero, is this zero going to stay the same or will it round up? So I think I just had an issue technically wise. You may not be able to see my screen anymore. I'm going to try to fix that. So I think I've been logged in twice. Hopefully you can see my screen again though. I think I logged back in for you to see my actual screen. If you can't see my screen, let me know. Okay, perfect. I'm glad you can still see it. I was worried we were going to have the same issue as last time. So, and that was the end of the problem. We found the volume, we rounded it. That's the correct amount. So next one, Tammy is roofing a house. She must buy enough shingles to cover. Cover is one of those key words. If you can't remember which one, I'm going to go back to the first page. Cover was a keyword for area. So now we know, even without reading the whole question, we're going to have an area problem. So buy enough shingles to cover the shaded rectangular areas on both sides of the roof as shown in the diagram below. What is the area she must cover? So looking at the shape, they tell you, I should have highlighted more key rectangular areas. So rectangle is, it is very light, can't see it. The picture itself is very light, or the entire screen? I'm going to stop sharing my screen and try and reshare and see if that fixes it. How about now? Did that make it any better? Oh, sorry, I just paused the share. I was trying to pause the recording. Okay, so we fixed it. You can now see the answers a little bit better. I wrote them out bigger, and I wrote out the units. We know we're doing rectangles because it wanted rectangular area. And we know we are doing the rectangles on top of the roof. There are 2 of them, but as long as we find the area for one, since they're the exact same size, they use the exact same numbers. They both have 15s, they both have 12 down here. So we can just find the area of one and then add it together with the same amount. So rectangles have an area of length times width. One side is length, one side is width. And again, they don't write that it's multiply, but we know now that anytime you see 2 letters next to each other, that's really multiply, length times the width. The only issue on this particular problem is they gave us the length. We know the length is 55 feet, but they did not give us the width. On our picture, the width goes from here to here, that I've highlighted in purple. The only numbers they gave us are the 5 to the left and the 12 on the bottom, but neither of those are the width. They're making you do a multi-step problem again and actually do something that's not area. This is still geometry, but this time I'm going to draw it bigger to the side. The left is the 5, the bottom is the 12, and this side was the width. And I'm going to go ahead and move the formula sheet out of the way so we have a little more room. So when you have a triangle, and specifically a right triangle, this 90-degree angle here means this is a right triangle. If you know 2 of the sides, you can find the 3rd side using the Pythagorean theorem. I'm pretty sure I'm going to look up the whole reference sheet. I only kept part of it because I didn't think we needed it. But let's see. They do not include Pythagorean theorem. So this is a formula you must have memorized. If you're making note cards or something, you may want to include this as one of your note cards. And it's a squared plus b squared equals c squared. So again, we need to know, what do each of these numbers, or sorry, variables mean? What does a mean? What does b mean? What does c mean? So when you have a right triangle, again, this only works for right triangles. The legs of the right triangle are a and b, and the hypotenuse is c. So I know that a and b are legs because they actually touch the right angle. C is nowhere near that right angle symbol, but A touches it and B touches it. Those are the legs. C is the hypotenuse, and it's nowhere near that right symbol. It's across from it. So we plug in the numbers we have. We know the 5 and the 12 are touching the right angle symbol. So those are the A and B. It doesn't matter the order. If you put 5 squared plus 12 squared, that would work out the same as doing 12 squared plus 5 squared. So to solve this, we kind of have to follow order of operations again, but we're also going to have to do some opposite operations. So when we follow order of operations, that means we're going to do the exponents before we do any addition. 5 squared, that's the same as 5 times 5, or 25. And 12 squared, that's the same as 12 times 12, so that's 144. Now these ones I know just because I have a lot more practice. I do problems like this all the time because it's my job. If you don't remember, plug it in. Calculators are great. So then we add the two together, get 169. And this is where the opposites come into play. We want this to just say C. We don't want that little 2 there. So opposites are weird. We're used to the basic opposites. Plus and minus are opposites. Multiply and divide are opposites. When it's an exponent, the opposite of squaring something is to square root. So we do the opposite and get rid of squared. And when we do the opposite, again, we're going to pull out our calculator. Most calculators have a little kind of check mark button. Oh, they put just square root over here. Notice this one had like a little 3, that one has a little y. We want just this kind of check mark button. So on this calculator, I have to do 169, then square root it that way. And we get 13. So now we know the width is 13. So we're not done yet. We always say, did we solve the problem? Well, this asked for the area that she has to cover. So we found the width, and now we need to find the area, the length times width. So we do length times width. I'm going to write it in this little space here. 55 times 13 is, this one I don't know off the top of my head. Oops, and that was a wrong button. So 55 times 13 is 715. So again, we have to make sure we're finished, even though 715's on our answer list. Answer choice A says 715. It says both sides of the roof, area of the entire roof. We only found the area of one side. Since both sides will have the same area, we can just add the two sides together. 715 plus 715 is 1,430. Oh, I'll circle the one that I wrote out so you can see it a little bit better. So always, always make sure you're asking yourself, did I answer the question? Am I answering what they want? Because out of the 4 problems we've done so far, only one of them stopped in the middle or stopped sooner. Most of them you've had to do multiple steps before you get to the correct answer. Okay, next one. A compound glue comes in a cylindrical tube. So cylindrical is important. Divided down the middle. Also important information. That means each side is half of the tube. To separate the glue agent from the hardening agent as shown. So 1/2 is glue, 1/2 is hardening agent. They never touch until you're ready to actually glue stuff. What is the approximate volume of the section of the tube containing the hardening agent? So approximate volume of the hardening agent. In case you can't see the answers again, I will write them out really quick if it's too blurry. And all of them are centimeters cubed. They all have the same units though, so I'm not going to take the time to write that. So We know they use the keyword volume. If we're picking from our formula list, we know we're picking a volume formula. And they said it's a cylindrical tube. So we know that in this case, we have a cylinder. So V for volume. I don't think I stated that before, but V stands for volume. Pi is still 3.14. R is still radius. So all that we've seen before so far. H stands for height. We've seen height on a rectangular prism. A cylinder also has a height. So on our cylinder, the height goes from top to bottom, and the radius is anywhere inside the circle from the center to the outside. So on our picture, they give us those numbers. 10 is the height, 3 is the radius. It looks a little funny, but that is the center of the circle. We're still going to the outside. And if you can't see that number, that was a 3. And this is a 10. They're kind of small. This time they didn't give us diameter, which is good. We don't have to figure out the radius. They gave it to us. We can go ahead and just plug those in. So we just had another student join. Thanks for joining. This is the OGT math prep course, and we're finishing up a couple problems. Right now we're finding the volume of a cylinder. So pi was 3.14 multiplied by radius squared. Radius was 3 and multiplied by the height of 10. So again, follow order of operations. We do not have any parentheses, but we do have an exponent. This time the exponent is in the center of the problem. It's still what we do first. We don't care if it starts on the left or the right or the center. If there's an exponent, we do that part first. 3 squared means do 3 multiplied by 3, which gives us 9. Now we are done with exponents. Multiply and divide we always do together, left to right. This case we don't have any divide, but we do have a couple multiply. So we just go from left and start multiplying them all out. 3.14 times the 9 times the 10 is 282.6. Now this time we don't even see the answer on the list. So we know either we did something wrong or we're not done yet. It might just be that you haven't finished the problem. So don't assume, oh, I did something wrong, I've got to start over. Double check. Always go back and say, did I answer the question? So the question stated, what is the approximate volume of the section of the tube containing the hardening agent only? We only want one side. So since the tube was split in half, we are not done. The entire volume was 282.6. We only want half of that. So 282.6 divided by 2 is 141.3. And again, when they use the word approximate, it's only going to be about that. So our answer is 141. They rounded it out. So one more question. Bart has a cylindrical pitcher with a radius of 6 centimeters. So cylindrical, radius of 6, and a height of 12. He pours 1,300 cubic centimeters of lemonade into the pitcher. Approximately how much more lemonade will the pitcher hold? So this time it's not asking specifically for the entire volume. It says how much more could we put into the pitcher. So here our keyword is into to know it's a volume. I was looking for that really quick. Usually when it's about drinking something, you're going to be doing a volume. Sorry for the background noise. So we know it's volume. We know it's not area. Crossed out too much. No, it's not area. We look for the shape now. It's a cylindrical pitcher. So we're doing a cylinder again. Same formula. But we're going to have to apply it a little, or we're going to have to do some extra steps at the end. Instead of dividing by 2 like our last problem, this time we're going to have to do something different because the situation is different. So we do 3.14 again times the radius squared, radius of 6. This time they just gave us the radius again. We do not have to divide by 2. When they give you diameter, you have that extra step. And the height of 12, h's height. And again, they just gave that to us. So this, and when you're thinking of it, you can even write out as you're doing your work, this is the entire volume of the cylinder, which is not the answer to the question, but it is what we're finding with the formula. So we plug this in following order of operations. 6 squared goes first because it's an exponent. I'm going to just type it in as 6 times 6, which is 36. And then we multiply all this out. Multiplication can just happen left to right. 3.14 times 36 times 12 is 1356.48. So again, we know that's not the answer because it said approximately how much more. They did include it. Answer choice D is that number rounded, but it doesn't answer the question. This is the entire volume, and we already have 1,300 cubic centimeters. They told us that in the question. There's no other way to know that unless they give you the information of how much you already have, or give you a way to find how much you already have. So how much more means we're going to subtract again. It's like that flag problem where we took the total area minus the area we found. We're going to take the total volume minus the volume we already know about. So we subtract it out. Is 56.48, which will round to the 57. And we always ask ourselves the question, did we answer? Is 57 how much more lemonade you could put in? 57 cubic centimeters. And that is the correct answer. That does answer the question. If you cook or bake, usually you measure volumes using cups. We have cups and half a cup and all that. Cubic centimeters is just a different way to represent that. So it's just how much liquid you can fit inside. We still have about 5 more minutes, so I'm not sure if I have another question or not. Oh, we do. So let's go ahead and do this one because we still have some time. So Jennifer wants to close off a rectangular area in her lawn so that she can leave her dog outside. She buys enough fencing to close off 252 square feet of lawn. If the length of the enclosure is 21 feet, what is the width? So you can do this problem two different ways. We know it involves area, so we know we'll need area formulas, specifically a rectangular area. But this is one where it's probably actually easier to try out your answer choices. I'm going to write each of these numbers a little bit bigger so it's easier to follow along. So instead of going through and solving, the easiest option is to say, well, I know area is length times width. And we know we want the area to be 252. We want this to equal 252. So we're going to just try our answers out. We know length is always 21. And we're going to try the different widths they give us for the answer. If we try 21 times 12, gives us 252. The very first answer choice gave us the correct area. So A is our answer choice. If you want to double check and make sure, you can try the other answers. 21 times 14 is 294. So answer choice B is too big. Did not come out with the amount we wanted. So that would be eliminated. It didn't work. So using your answer choices can be a great way to make the test go faster and cut out some of the work you have to do. The long way of doing this is to take the information they gave you and plug it into the formula. I'm going to move stuff to the right again so we have more room. So we've already solved the problem using the answer choices. A great method. Here's a second way. If I can get it to right up. Okay. Option 2. We know the formula is area equals length times width. And they told us the total area. This is A. And they told us the length. So we're going to plug those in. But we still have W because that's the one we don't know. So once we've plugged in the numbers, now we have to solve for W. So this way it's not really that much longer, but it does take a little more thought process. We say, well, if I'm going to solve for W, I've got to do opposites. When we have an equal sign, we're going to do opposites to move numbers across each side. So since this is 21 multiplied by W, to move it to the other side away from W. Normally we've been working left to right, but an equation you always want to get stuff away from the letter. So we want to divide by 21 because that's doing the opposite, and it gets rid of the 21 that was there. So then we just have to plug that into a calculator. 252 divided by 21 is 12. So we still came out with the same answer, still got the correct answer, just a different way to do it. So we are out of time. We will be doing these every week. We're still waiting for updates to get the exact dates when you can test. As soon as Amy knows, the testing coordinator, she'll let everyone know. And we didn't talk about all the shapes, so I may include some more practice on volumes and areas next time so that we cover all the shapes. We've only seen some of them. Please also let me know if there's any specific topics you want to cover, anything you're really worried about, and we can focus on that as well. So thanks for coming today. I hope to see you again next time.